Hi, in this video we're going to talk about Graham's law. Now, to talk about that, we first need to know two vocabulary terms, and that is diffusion, which is an even distribution of gas particles, and effusion, which is movement of gas through a hole. And our Graham's law states that kinetic energy is determined by temperature. If temperature is constant, kinetic energy will be constant. Heavier molecules move slower, and rate of diffusion is inversely proportional to the square root of its molar mass. And it basically states that rate of A divided by rate of B is equal to the square root of molar mass of B divided by molar mass of A. And that will equal to how fast, how much times faster, times of speed. So how much times faster a substance is compared to the other. Now let's do some example problems. To start off, we have under the same conditions, temperature and pressure. No, under the same conditions of temperature and pressure, how many times faster will hydrogen diffuse compared to carbon dioxide? Now here's the thing, how do you know which of them is A and which of them is B? So if the speed is greater than 1, place a heavier, if the times of speed is greater than 1, place a heavier one element on the top, and to get a number greater than 1, right? If the speed is slower than 1, place the heavier one on the bottom to get a number less than 1. So over here, in this case, let's see which one is lighter. First, you need to find which one is lighter, because heavier molecules move slower. So how many times faster will hydrogen diffuse compared to carbon dioxide? Hydrogen is the lightest thing you can see, fine. So hydrogen will travel a lot faster than carbon dioxide. So the times of speed will be faster, like we can say hydrogen travels 4 times faster, 5 times faster. So we know our number has to be greater than 1. So that means in order to give us a number greater than 1, the bigger number has to go on the top. And the bigger number will be carbon dioxide in this case, which is 12.01, plus oxygen, which is 16 times 2, which is 44.01, divided by 2.02, to give us a number greater than 1. And that gives us about 4.67 times faster. And now, what is our rate A and what is our rate B? Well, A in this case is equal to hydrogen, and B in this case will be carbon dioxide. So there's no rule of which one goes on top and which one goes on the bottom. You're just gonna see what you're given with. Now let's answer a follow-up question. If the CO2 in problem 1 takes 32 seconds to diffuse, how long will the hydrogen take? Okay, so CO2, which travels slower, takes 32. So how long will hydrogen take? Hydrogen travels 4.67 times faster. So our number will be about 4.67 times smaller than 32. And to do that, we simply divide it by 4.67, and that should give us 32 divided by 4.67, which gives us about 6.85 seconds. Now this makes sense, right? Hydrogen, because it's lighter, it will travel a lot faster, which means it will diffuse in 6.85 seconds, whereas something heavier like CO2 will take 32 seconds. Now question 2, it says, What is the relative rate of diffusion of NH3 compared to He? Helium. Does NH3 diffuse faster or slower? Now, which one's heavier, NH3 or He? N is 14.01 plus 1.01 times 3, and He is helium, 4.003. Alright, so NH3 is 17.04. He is about 4. It said, will NH3 travel faster or slower? Well, it's kind of obvious here, right? Since NH3 is much heavier, it will travel slower. And traveling slower means the times of speed will be less than 1, right? If you travel 0.1 times as fast as something, that means you're actually 1/10 slower. And so to get a number less than 1, in order to get a number less than 1, the lighter one has to go on the top and the heavier one has to go on the bottom. And if we plug into our calculator, we have 4 divided by 14.04, and that gives us 0.485 times. So this is telling us that NH3 diffuses 0.485 times slower than He. And what is our rate of A? Rate of A is rate of NH3. Rate of NH3 divided by rate of He gives us this, which gives us our answer of 0.485. Now the follow-up question states, if the He takes 20 seconds to diffuse, how long will NH3 take? Alright, so Fe, the faster one, took 20 seconds. So how long will NH3 take? That means NH3 has to take longer, right? So if we divide this by 0.485, which is a smaller number, we have 20 divided by 0.485, which gives us 41.2 seconds. And now this makes sense, right? NH3 is heavier, which means it will take longer to diffuse. And now let's do our final question over here. We have an unknown gas diffuses 0.25 times as fast as He. What is the molecular mass of the unknown gas? So we have an unknown gas and diffuses 0.25 times as fast as He. So we have He on the top and this heavier element on the bottom, because if you divide something smaller by something heavier, you get numbers less than 1. In this case, we want a number that is 0.25. So what does that mean? That means we have rate of X divided by rate of He will give us He on the top and X on the bottom, which gives us a number smaller than 0.5. And X has to be bigger than helium since it diffuses slower. So we have, let's square both sides, which gives us 0.25 squared. We have 4.00 divided by X is equal to 0.0625. Now we divide 4.00 by 0.0625. That gives us X is equal to 64. 64.0 grams per mole. And that unknown gas will travel 0.25 times as fast as He because it is heavier. Now the only thing that you need to be careful of this is which number to put on top and which number to put on the bottom. And to do that, all you need to use is your common sense and to know that the heavier molecules travel slower and the lighter ones travel faster. Then you just rearrange them to see which way it will give you the desired times of speed, depending on whether it's faster than 1 times or slower than 1 times. Thank you for watching.